So in our previous videos, we discussed basic electronic components and we said that we will come to diodes back and we will see how they work and how all the electronic components and appliances nowadays are made out of these very basic units here. So in this video, we will construct our own BJT out of two diodes and then we will use that BJT to construct the basic logic gates. So diodes come in all different shapes and sizes. These ones are Schottky diodes. This one is a Xeno diode. This is an LED, which is also a diode, but this one, the LED, emits electromagnetic waves when current passes through it. All these components here are made out of diodes. This is a motor driver module. So this IC is made out of MOSFETs and MOSFETs are made out of diodes. This is a counter IC, this is an op amp, this is a 1000 AC to DC rectifier, this is an LCD, this is a pulse generator, a laser module, a MOSFET, and of course a BJT. So all these are made out of diodes. So we will construct our own BJT and then using that BJT we will construct the very basic electronic logic gates. So we will construct an NPN transistor. So that means that on the terminal sides there are going to be negative sides of the diode, and in the middle we combine these two and that will give us a positive terminal, just like that. You can see that the negative sides are on the terminal sides and in the middle both the positive sides are combined and it gives us this positive terminal. So let's see if we can use this very basic BJT as a switch circuit for an LED. So we'll connect an LED to the emitter side just like that, and then we will attach a header for the ground. Then we will attach a 10K resistor to the base of this transistor and we will attach it to the positive side of the transistor just like that. On the positive side we will add a header and now we will attach a push button to the base of the transistor. Now we will attach the circuit to the power supply and if I press this push button the LED is supposed to light up. So this circuit proves that transistors are made out of diodes. So now we have made our own BJT. So instead of these diodes, now we will use this NPN BJT to construct the very basic electronic logic gates. So the constructed circuit here is an AND gate and the schematic diagram for that gate is here. So in a statement, AND gate would work when both switches A and B are pushed. So you can see pushing either of these won't turn on the LED. Now we will push both of them together and then you will see if this LED lights up. So here we go. And if we press both, the LED will turn on. Here is the short circuit diagram of the AND gate and here are the two switches. When you close the switches, the LED turns on. So in a statement, an OR gate would work if either the switch A or B is closed. So if I push either of the switch, this LED is supposed to turn on. And let's see. And if I push both of them, this will still turn on. So now the circuit here is based on the schematic and this is an OR gate. And this is the short circuit diagram for an OR gate. The circuit that you see right here is a NOT gate. NOT gate in a statement would work if the switch is not closed. So let's close the switch and if see that statement really satisfies this logic. So when I push the switch, the LED turns off. This circuit is based on this schematic. You can see that if the switch is closed, the LED on the output turns off. This is the short circuit diagram. And short circuit diagram for some reason doesn't work here, but logically it is supposed to work because all the current would flow here in this direction. Current will always flow in the path wherever there is least resistance. So I guess that's one way to know that real and imaginary systems are way different than we think. So BJTs don't make very good components to be used in an electronic circuit, and the reason for that is that they cannot withstand a little more than just 5 or 6 volts at 2 amps. So here's this BJT that we worked with earlier and I've just put this protective cap on top of it because I don't want to shatter any silicon pieces into my room. Here we go, we will just increase the current and see the behavior of the BJT under that cap. Well, you can't see but you'll know. and just like that, it's dead. Wow, that's like a lot of smoke. Oof, smells terrible. So this BJT right here is now dead. And I will zoom in on this BJT to show you the amount of destruction that a little more than 5 volt has caused. So that's it for today guys. Thank you so much for watching and we will see you next week.